Procedure for hypothesis tests. Step 1 and 2. State the claim and the opposite of the claim, and then identify the null and the alternative hypotheses. Now, the null hypothesis is denoted by capital H with a subscript of 0. This is a statement that the value of the population parameter, such as proportion, mean, or standard deviation, is equal to some claimed value. When testing a hypothesis, always start by assuming that the null hypothesis is true. Then use evidence to reach a conclusion. Now again, the null hypothesis, the one key thing is it always has the equal to or the equal sign associated with it. So here are some examples of the null hypothesis where P is the population proportion is equal to 0.5. Or the null hypothesis where we have the population mean, which is equal to 12. Or we have a null hypothesis where the population standard deviation is equal to 2.56. Next, we have the alternative hypothesis, which is denoted by the following: capital H with the subscript of 1, or capital H with the subscript of lowercase a, or capital H with the subscript of capital A. For this course, you'll see H subscript 1, but these other forms may be in other particular courses. This is a statement that the parameter has a value that somehow differs from the null hypothesis. For the methods of this chapter, the symbolic form of the alternative hypothesis must use one of these symbols, either less than, greater than, or not equal to. So you can see the difference between the null hypothesis and the alternative. The null has the equal sign, whereas the alternative is going to have a less than, greater than, or not equal to. Now, below here are different examples of alternative hypotheses involving proportions, means, and standard deviations. So the proportion, you can see what the alternative hypothesis is going to be. It can either be the proportion which is not equal to 0.5, the proportion can be less than 0.5, and the proportion is greater than 0.5. If we look at the mean, the alternative hypothesis would have the population mean not equal to 12, or less than 12, or greater than 12. And then for the standard deviation, the alternative hypothesis would have the population standard deviation which is not equal to 2.56, or less than 2.56, or greater than 2.56. Okay, so now how do we identify the null in the alternative hypothesis? Well, first we want to state the original claim symbolically, and then we're going to state the opposite of the original claim. Now, the original claim could be the null or the alternative. It just depends on where the equality is. So let's take a look at one example here. It says the mean of a fluid is at least 12 ounces in a can. So we need to take a look at that at least. So the at least is what's important here when we see that, at least 12. Okay, so we first need to find our claim. Well, recall that at least means greater than or equal to. And so we're also talking about the mean. So the mean is then going to give us the symbol of mu. So we're going to say that the claim is the mean which is greater than or equal to 12. Now, what would be the opposite of this? Well, the opposite of greater than or equal to is going to be less than. So the opposite would be that the mean is less than 12. Okay, now keep in mind that if we come back up here, the null hypothesis always has the equal sign, and the alternative is going to have either the less than, the greater than, or the not equal to. So if we take a look at the claim and the hypothesis, the line under the greater than symbol tells us that the claim here has the equal sign. So that means that we would say that the null hypothesis has the mean which is equal to 12. And then we would say that the alternative would then be the opposite here. And the alternative would be that the mean, the population mean, is less than 12. Okay, let's take a look at another example here. It says the proportion of female CEOs is greater than 0.5. So here it says is greater than 0.5, and we're talking about the proportion. So let's first start and look at the claim here. Well, the claim, you can see, has the following. We have the symbol for P, and you can see that it's greater than 0.5. So therefore, now we need to look at the opposite of that. Now, what would be the opposite of this? Well, the opposite would then be less than or equal to. So we would say that the proportion is less than or equal to 0.5, since that's the opposite of greater than. Okay, now remember and keep in mind that wherever the equal quality is, that's where you're going to then define the null hypothesis. So here you can see that this has the equal sign in the opposite, so that means that the null is going to be the proportion, which is equal to 0.5. And because the equality is not in the claim part of it, then we would say that the alternative is going to be greater than 0.5. Okay, so therefore that's going to be greater than 0.5. Let's take a look at another example. It says the standard deviation weight of babies is at most 2.56 pounds. So we're saying at most 2.56 pounds, and we're using the standard deviation. Okay, so we need to make sure that we're comfortable with what at most means. So in our claim, at most is less than or equal to. So we're using standard deviation, so that is the symbol, and it says at most, which is less than or equal to. So we can see that the equals is going to be in the claim. So now what is the opposite of the claim? Well, the opposite of the claim then would be that the standard deviation is going to be greater than 2.56. So since the equal sign is going to be in the claim, then we would say that the null has the population standard deviation, which is equal to 2.56. And then the opposite would then be the alternative, which would be the population standard deviation to be greater than 2.56. Okay, let's take a look at the last one here. The mean IQ score is 100. Okay, is 100, what does that represent? And then we're talking about the mean. Well, is means that it's equal to 100. So therefore, the claim would then be mu, which is the mean, and we can say that it's equal to 100. Okay, now what would be the opposite of mu being equal to 100? Well, the opposite would be mu is not equal to 100. So now how do we form the null and the alternative? Remember, the null always has the equality. So the null hypothesis would then be that mu is equal to 100, and therefore the alternative is going to have the not equals, right? So therefore there are our examples. So let's go back up here and take a look here. Remember that the null always has the equalities, and the alternative is either going to have the less than, greater than, or not equal to. So let's check. We have the equal in the null, and there's less than in the alternative. We have the equal in the null, and then there's a greater than in the alternative. We have an equal in the null, and the greater than is in the alternative. And then we have the equal in the null, and then not equals in the alternative hypothesis. Okay, now note about forming your own claims hypotheses. If you're conducting a study and want to use a hypothesis test to support your claim must be worded so that it becomes the alternative hypothesis and can be expressed using only the symbols less than, greater than, or not equal to. You can never support a claim that a parameter is equal to a specified value.